Jackson Systems is your leading provider for HVAC controls, with products like our award-winning zoning solutions that completely eliminate the need for bypass dampers, our filter fetch service that pays you while homeowners get the filters they need, thermostats imprinted with your logo, complete home and business automation with connected thermostats, cameras, and intelligent Wi-Fi solutions from Nest, Ecobee, Honeywell, Google, and more. Visit us at jacksonsystems.com to see the products that continue to win industry acclaim among contractors across the country. Jackson Systems, controls done right.
Welcome back to another episode of The Tradesman. I am Zach Ciota, the aforementioned tradesman, and we're talking about manual D, duct sizing, duct design, all that good stuff. But today, we're going to concentrate on one particular aspect of this process. We're going to get into the friction rate worksheet, but the first thing we have to do is figure out what kind of blower speed, and tap we're going to design for. Now, what I've done, I've gone to the internet, our good friend the internet, and I'm looking at an ARUF 25B14 air handler. It's really easy to find the blower data for this air handler. It's a Goodman air handler. It's a very common air handler. ARUF is their basic line of air handlers. You type it in on the internet, it pops back up. It's got a PDF. At the bottom of the PDF, you have airflow data. So we're going to look at using an ARUF 25B14 air handler with a 2-ton outdoor unit. Now, I don't remember exactly what the model number is. I'm thinking it's a GSZ, but that's irrelevant. We just need to know that it's 2 tons. We're going to design for a nominal CFM, which is 800 for 2 tons, basically 400 CFM per ton. Just a rule of thumb we go by. Sometimes that will be adjusted a little bit based on where you are in the country, cooling loads, but we're just going to use 800 because it's easy to remember, and we're trying to keep it basic for this particular lesson. So I'm looking at this air handler. Again, ARUF 25B14. This has a 3-speed blower, low, medium, and high. It gives you a static pressure, and it gives you a CFM for each one of those speed tabs. So for example, the first static it shows on the chart is 0.1. It's a very low static. In the real world, I don't know the last time I've seen a 0.1 static. It's usually at the other end of the spectrum. But for the purpose of our talk here, on low speed, that will give you 650 CFM. So right off the bat, you know we're not using low speed. Because even at the smallest amount of static, we're still not anywhere near 800 CFM. So it's not going to be possible to push the amount of air we need on that speed tap. That speed tap's out. Just for reference, if we go up to a normal static, which is 0.5, we're pushing 490 CFM, which is roughly half what we need, a little bit more than half. And if we get up to 0.7, we're at 275, which is pretty bad. So why would this air handler even have a low speed tap? Because in a world like ours, sometimes you match 2-ton air handlers to 1.5-ton outdoor units. So theoretically, we don't need that 800 CFM. We only need 600. Or if you're designing for a high latent load, maybe you're dropping that number back to 350 per ton. So you're less than 600. So that would be one of the reasons why you might have that low speed tap. So let's go on to medium. We'll just describe the spectrum here. We start at 0.1. We have 885 CFM. So here we are. We're getting closer to what we need. So let's go up to a normal static, which is around 0.5. 750 CFM. 750 is not very far off. In fact, that's 375 CFM per ton, which is a perfectly good number. That's not so low that you're going to have issues. You'll get a little bit higher latent capacity. The sensible heat ratio will change a little bit. You'll get more latent and less sensible removal. If we go up to 0.7, we're all the way down to 560 CFM. So it falls well below the level we need. So we go up to high speed. At 0.1 static, on high speed, we're at 1255, which is even more than a 3-ton unit. So that's way too high. And in fact, when we get to 0.5 static, we're still at 965. So it's not until we get all the way to 0.7 static, which would be a duct system that has issues or with improper filtration, we're down to 800 there. So more than likely, let's go ahead and choose our medium speed tap. We'll have that in mind. And we can design for a 0.5 static to give us 750 CFM, or we can design for a 0.4 and get 815. Actually, we can do 0.45, but for the purpose of this exercise, we're actually going to choose a medium speed tap and a 0.5 static. So that's all we want to talk about. Nice, short, and sweet podcast right here about selecting what speed tap and what static we're going to design our duct system for, because we have to be realistic. We're not going to go in there and design for a 0.1 static duct system, because after you take off the dampers and the takeoffs and the stuff that's already in the duct system, which you take off, including the filter, you're already going to have a negative static, which is not going to be very good. In fact, that's an impossible situation. So that's not going to work. Typically, when we're using a friction rate worksheet, there's a few items that are always on there that's going to take away from the static we start with. Because we're going to start with the static pressure that's on the blower chart here, and we're going to work back down to what's called the available static pressure after we take out all these devices. Some of the device pressure losses, that's what they're called, because each device that gets in the way of the airflow is going to cause pressure loss. Basically, it's blocking the airflow. So we have things like the filter, which can have a wide range from maybe 0.1 to 0.3. It can be a very wide range. I've seen pleated filters that run 0.25, 0.3, just regular grocery store filters that are pleated. They're way too high. That's one of the reasons why a lot of our guys say don't use those, because they're so restrictive. When the duct system is sized and you have that filter in that duct system, there's not enough area to permit enough air to flow through there. Even though you might have better filtration, which really with the grocery store filter isn't all that great anyway. A media filter would be better, and some of the pressure drop is actually lower on the media filter. So we have things like the supply outlets, return grills, the balancing dampers. All those things take away from the static you start with, and you work your way down to the available static pressure. And then we'll go from there next time. That's all we're going to talk about. Next time we're going to fill out our friction rate worksheet as far as our static pressure losses, and we're going to get our available static pressure. But we're going to take it one step at a time. Make sure everybody understands. It's really easy to find a friction rate worksheet online. Just search friction rate worksheet PDF, and you'll see about a zillion of them. And they're all about the same. So you can find that. You can find the information for the ARUF25B14 at the Goodman Manufacturing website, or just search for that model number in PDF, and it'll pop right up. And you can study right along with me. In fact, it'd probably be a good idea if you went ahead and just got the sheet and then listened to the podcast. It'd be really easy. That's about it, guys. I don't want to talk too long about this stuff. I'm trying to do little bits and pieces here so everybody can understand and follow along. Don't forget, our good buddies Jackson Systems, whose ad you heard at the beginning of this podcast, are having a huge sale on combustion supplies. All your boards, igniters, and things like that. They have a ton of that stuff, along with their existing services such as thermostat imprinting, zone supplies, a lot of great stuff. So check them out at jacksonsystems.com. Check out that program. Might be perfect for your company. Otherwise, stay tuned next time. More Manual D stuff. We're going to keep rolling with this stuff. People seem to like it. I'm enjoying talking about it. It's been a lot of fun because duct design is one of the things I've done for a long time. Even before I did service, I did design and load calculation. So this is right up my alley. Because you know me, guys. I'm Zach Ciota, and I am the tradesman. Guys that have listened to us at HVAC Shop Talk for a while have heard us talk about getting a free Zoom Lock toolkit with the purchase of a certain amount of Zoom Lock flame-free refrigerant fittings. Well, that's true. If you purchase 350 of the flame-free Zoom Lock fittings, you can get a free tool with that. But what you might not know is if you go to the Zoom Lock Roadshow and make that purchase, you can get it for 300 Zoom Lock flame-free refrigerant fittings. That's quite a deal, guys. Go to ZoomLockRoadshow.com and find out where that truck's at so you can flag it down and get your Zoom Lock tool today.